Welcome to Spring LIB.
All right, so we have that some substrate with some reaction conditions gave the product. All right. So this is a so-called epoxide. Okay. And what's interesting about epoxides is that they're somewhat related to alkenes. Epoxides are, in fact, often called alkene oxides. And the idea here is that their reactivity is somewhat similar to alkenes, and they're often made from alkenes. So they, in some respects, behave like alkenes. And that's why they might be also called alkene oxides. Okay, how are they made? Well, the general pattern is that you have some alkene, and you react it with MCPBA, which is basically it's a peroxy acid. There's other versions of this peroxy acid. It's an oxidizing agent, but a somewhat mild one. It will oxidize the alkene to instead give you an epoxide. And the one thing that's cool is that any groups that were previously trans in your epoxide, like these two methyl groups, right, will be no longer trans because it's not really a double bond anymore, but they will be anti to each other. So another way you could draw this is that you draw your epoxide, and that because this methyl group and this methyl group are trans, they will be anti with respect to the epoxide, like so. Okay. And if they had been cis, they would remain cis, right? So if we think about this backwards now, if we want to go from epoxide to alkene, how do we do that? Well, we basically think about chopping off that oxygen and putting a double bond where the single bond is between the two carbons that are bound to oxygen, right? So that's exactly what we need to do here. We need to think about chopping off this oxygen, not there anymore, and then putting a double bond right there. And what would that look like? Well, for one, these methyl groups would no longer be wedges or dashes, right? They'd be flat because it'd be a flat alkene, and we just wouldn't have the bonds to oxygen anymore, right? So we basically just draw the same thing that we have right over there. Right, I'm going to draw the exact same skeleton. I said these methyl groups will no longer be hashes, they'll be on wedges. And where I have the dotted line there in my alkene, it'll be a double bond, right? And as I said, the reagent to achieve this is MCPBA, or if there's other options, anything that's referred to as a peroxy acid. But this is by far the most commonly used peroxy acid. It doesn't show the reagents, but if they also say anything about Swern oxidation, which involves H2S. If you see H2S and a bunch of other reagents that you don't recognize, or if you see the word Swern, that's another set of conditions, another set of reagents that can turn an alkene into a epoxide.